Hello students, welcome to Solves classes. Today we'll be solving the CSIR UGC net questions from the June 2018 paper. We'll be solving the set C of the mathematical sciences paper. Let's start off with question number 63. In question number 63, we need to find out that which of the following sets are uncountable. Option 1, the set of all functions from R to the set 0, 1. Option 2, the set of all functions from N to the set 0, 1. Option 3, the set of all finite subsets of N, and option 4, the set of all subsets of N. Now we know that every sequence are basically functions from N to R, are basically functions from N to R. This is what we know. And also set of all sequences formed by either 0 and 1 are uncountable. So these are the two statements that we should care about. So now it has been said in option 1 that the set of all functions from R to 0 to 1 is uncountable. So basically we can say that option 1 is correct, since we have already said that set of all sequences which are formed by 0 and 1 are uncountable. Similarly, option 2, which says that the set of all functions from N to the set 0, 1 is also uncountable. This statement is also correct. Now let's shift our focus to option 3. Now in option 3 it has been said that the set of all finite subsets of N is uncountable. Let S be the set of all finite subsets of N. Now if S is the set of all finite subsets of N, then we can write that S is equal to union of Sn, where n goes from 1 to infinity. Now you might be wondering that what is Sn? This Sn is basically nothing but the finite subsets of n with small n elements. Now we know that since Sn is a finite subset of n with n elements, so basically Sn, we can say that Sn is countable, and we know that the union of countable sets is a countable set. So therefore S is also countable. So statement 3 is false. Statement 3 is false. Now let's shift our focus to the option 4. In option 4 it was said that the set of all subsets of N is uncountable. So let us deal with this. Now we know that by Cantor's theorem, now what does the Cantor theorem say? The Cantor theorem says that if we have any set A, for set A, the set of all subsets of A, which we can denote by P of A, has strictly greater cardinality than the set itself, than A itself. So what we can then therefore write? So we know that cardinality of the set N, basically the cardinality of the set of natural numbers, is, we can definitely say that this is countably infinite. And we also know that from Cantor's theorem that for set A, the set of all subsets of A has strictly greater cardinality than A itself. So we can say that therefore by Cantor's theorem that cardinality of all subsets of the set N is greater than the cardinality of the set N itself, which is, and the cardinality of set N is countably infinite. So therefore we can definitely say that cardinality of the subsets of N is greater than countably infinite. Okay, so this is a statement we are getting. So if cardinality of Pn is greater than countably infinite, then we can say that cardinality of Pn, which that will be equal to the cardinality of the set of real numbers, and that will be uncountable. So therefore option 4, which says that the cardinality of all subsets of N is uncountable, is true, and therefore option 4 is true. So the correct options are, let me write it down over here. Correct options are option 1, option 2 and option 4. These are the correct options. So today we have solved question number 63 from the CSIR UGC NET question paper of June 2018. We will be solving the next questions in the subsequent videos. Till then, keep watching Softsource classes videos for more solutions and content.